What's happening? My name is Danny Zapata from Cal Poly San Luis Obispo.
I'm Paul Rodriguez.
And what we made was a solar tracker for our 329 project. Paul, can you explain some of the circuitry?
Our solar tracker consists of two major sensors. One is our photo sensors, which we made. We made both our sensors, which is the photo sensor and the power sensor. The power sensor is actually a current sensor, which senses the current going through this 100 ohm resistor, which then turns into a voltage that goes into the A to D. The photo transistors go into a current mirror that we designed over here, which goes into an op amp, which also converts that current into voltage for another A to D that we used. And James will talk about it.
Cool. So I made a little PowerPoint real quick to explain how the code works. So what we have is the sun, and pretty cool sun. So these two yellow marks, it should be orange and yellow, is our sensor. So we'll say that there's more light on this sensor right there. So what happens is it goes through the A to D from, I think the voltage is, what's the voltage again?
If they're equal, it's at 2 volts. If one's greater than the other's at 3 volts. If one's less than, it's at 1 volt.
So I take that value so if the value is less than 1800, it will output a clock and output it counterclockwise to the stepper motor. So we'll say that there's more light on the left side, and that value has less than 1800, so it outputs that, and it goes down to our stepper driver, which is on our circuit board, and it turns the motor counterclockwise 1.8 degrees, and it keeps on going until it hits the right side, meaning that there's more light on the right side. And if it's greater than 2300, it's going to output a clock and output clockwise signal to the stepper driver to move 1.8 degrees clockwise. So what we're trying to do is look for a range in between, right? Between 2300 and 1800. So if it's in between that, which we have here, you won't send a clock signal and we'll turn the switch off. The purpose of the switch is not to drain the battery, because it's a stepper motor. You need current running through the motor to actually hold it in place. So once the switch is off, we put it for a wait for about 15 minutes, a little for loop, to check the sun every 15 minutes, 10 minutes, and then it turns back on and it starts all over again. So quick demo. Go ahead and hit the lights. So what we have is our batteries. What we did last time is we ran everything through the computer, but this time we actually used the PROM or the RAM on there and actually stored the code on the memory on the board.
And we added the switches down here, sunset.
Yeah, these switches right here basically is going to tell it that it hit sunset, and then it's going to start resetting back the panel to the
sunrise,
facing the sunrise.
So there, he hit the switch, and he's going to be ready for the next day.
So it's not
sunrise.
So it hits the switch back over here, and then it waits, and then the light's going to act like our sun. So it starts following the sun. Cool. And then another thing that we added was our power meter. Paul designed a power meter somewhere in here. I don't know where at. And we were outputting 0.6 watts right now because we're not out in the sun. But we have a video to show you real quick to show that demonstration. Paul, want to get that ready? Come over here, and you look at the LCD monitor, you are reading a power of 2.7 watts. Now if you turn the solar panel a little bit away from the sun, the wattage will drop. 2.4 watts, 2.1, and then if you try covering it up, down to 0.6 watts. Now if you turn it back to the sun, it goes up to a maximum 2.7 watts.
Lucky.
2.9. Lights. Nice. So yeah, so we can't demonstrate that in here, so we designed a quick video. What else do we have? Well, yeah, so I mean, this is our circuit board that we have here. And then there's just a bunch of circuits.
That's mostly all the circuits for the control of the stepper motor and all the power that powers the rest of our circuits. This half is the battery charger we made. Right now we just have this 100 ohm load on it to get a constant reading because the PV depends on the load. And that's it.
That's basically it.
Great.
Thank you.
Thanks, guys.